Start. Cool. Okay, hi. Welcome to the unofficial ADE version of DigitalOcean Amsterdam here at Your Majesty in Amsterdam, which is good. I'm David. I'm the guy who sends out all the emails. That's me. I'm your host. We actually went through a couple of iterations for tonight's title. This is kind of what we ended up with, but in the meanwhile, we were like, maybe we could do official ADE pre-drinks, but we weren't official, so that kind of went out the window. Yeah, we also considered the friends of friends who do cool things with music and technology, but that was also quite wordy, so we kind of killed that one as well. So we settled on an unofficial ADE special, because that's what it is, and I keep saying man, you guys are going to make a mixtape. So the main reason I'm hosting tonight's meetup is because I really want one of these cubes. You can see them all over Amsterdam at the moment, and I saw one a few years ago, and I've really been trying to get one, but I can't do it. It's super annoying. They're all over the playgrounds, and I applied to be part of the playground schedule, so I crossed my fingers, but we weren't successful. So here we are, unofficial, cubeless. One day I'm going to steal one, like this guy, and yes, we will have one for next year. These are all official photos from the ADE press office, so I thought this was quite entertaining. But you guys turned up, so I'm super grateful for that, and I really appreciate it. There's a few formalities we've got to go through before we begin. Toilets are behind you, just over there, the guys and girls all there. Hopefully there's a toilet roll. If you smoke and vape, you have to go downstairs, just outside. It's totally fine. And that's good. And then there's a table of stickers just over there. Hopefully you saw them. And there's sharks as well. You can steal those if you're feeling really stressed. There's also snacks and racist snacks, like for Christmas. I had a slide for this, but I was kind of like umming and ahhing whether I'd mention it. I've mentioned it now, and so there we go. We're done. Dutch traditions, that one. The Wi-Fi name, which you can't see because I changed the slide, is you actually guessed, and the password is Cavalier, which is quite difficult to spell. Going forward again, and if you're tweeting, hashtagging or whatnot, you can use the DO Meetup hashtag, and that'd be great because then we can find it and like it and share it more. So that's what we want. And there's that guy stealing the cubes. I wanted to thank a few people who made this meetup possible, because I can't do it on my own. First is Abril, who you hopefully saw on the way in. She gives you the stickers, make sure you're still here so I know how many people turned up. Then we've also got Hugo, who runs the live stream. This is him looking particularly intellectual over wines. This is in Italy. It's a very recent photo. Hugo and I will be floating around all evening. If you have any questions, you can ask us, or there's the YM team, Casper's about this time, which is nice. And I have the same slide twice. And then agenda for tonight. So, you managed to make it here, grab a drink and find a seat. This is the introduction. Coen's going to give us a talk. He does lots of things on modular code, and he's done game engines, working with like Hardwell and stuff like that. Yeah. You do a much better introduction than I will. I'll go through that part. Yeah. That's important. You do that bit. It's got like Unreal Engine 4, lots of like really cool stuff. Then we got a break after that. You're going to have a chance to get beers. We've just topped them up, so that's great. And then straight after that, we've got Ben. He jumped in like literally yesterday, and I'm super grateful. We lost our other speaker because they couldn't do it because they were super busy. And I sent Ben an email, and he was like, "Yeah, I'll do it." And I was like, "Fantastic, amazing." So he's going to give us a lightning talk. 10-20 minutes. Talking about his non-linear sequencing software that he's built, which is pretty cool. So it's all music technology this week, and that is that. Pizza turns up at 8:30ish, so that will be good. I'm looking forward to that. There's other house things to be done. Emergencies. If there's a fire, if somebody spontaneously combusts because they really love Unreal Engine or something, I don't know. There are fire exits. There's one over there. You have to climb across like plant pots and stuff, but it's kind of different, but it works. Failing that, you can go in where you came in and go down the stairs, and there's a bridge over there, and you can congregate and chat over beers, and then they'll put out the fire, hopefully. That's that. And then if you hurt yourself for some reason, I don't know, you fall on a beer or something, we've got paracetamol or drugs, and not those kind of drugs, but there's lots of things, and then we can call ambulances if it's really super serious, but hopefully it's not, and hopefully none of that will happen, and we can just get through the evening on beers, and then it'll be fine. We've got it covered. I've got all the gifts to make this happen. This is the most serious slide of the evening. We have a code of conduct. A few people asked me why we have this. Basically, I want to be like a conference. This outlines the kind of protocols that are in place. It's just good practice. Everyone knows where they stand, and yeah, if anything happens, we can be like, these are the rules. So I'm not going to go through it. It is actually longer than this. This is like a short snippet, and I'll read the first word, the first sentence, and everyone can laugh at the technology choices bit. DigitalOcean is dedicated to providing a harassment-free event experience for everyone, regardless of gender, gender identity and expression, age, sexual orientation, disability, physical appearance, body size, race, ethnicity, religion, or lack thereof, or technology choices. So if you like Linux, that's totally fine. If you like Windows, that's also totally fine. But we just treat each other like nice, and then that's it. There is a full version on the Meetup group right at the bottom. You can click on the link and you can read through it to your heart's content. If you feel like you can't adhere to this and you're feeling mean tonight, you can always leave. And nobody's left. That's good. If there is an incident, you can find me or one of the YM team, and we will deal with it. You can always send an email to myself or a tweet to myself, or Samantha. She runs the DigitalOcean meetups globally. All the details will be on the last slide. So there are people. We can sort this out. But hopefully we won't need to. We got a few words from the sponsors. This is the Your Majesty logo, and obviously DigitalOcean, who paid for all the things. So DigitalOcean, they paid for the beers, pizzas and snacks. They also gave us all lots of free swag and sharks and stress toys. They are the first cloud hosting provider to use solid state drives everywhere. You can create a droplet in like 55 seconds, which is just like this. And it really is the bee's knees. You can do more or less anything on these things. It's so super simple. You spend less time smashing your computer up and getting really angry. I mean, you can still do this. It's still coding after all. But you don't have to worry about servers. So that's nice. And instead, you can do this, which is, generally coding things. And then Your Majesty, these guys provided the venue. I work for Your Majesty. We are a design technology firm that powers digital product and brand experiences for some big companies that you may have heard of, like Netflix, Adidas, Samsung, and Spotify. We have fancy logo, which is a GIF, and I always make the same joke that it's really hard to print. But what does this mean? Well, this is kind of relevant because Coen actually helped us do this. But we create cubes, and we distribute them across lots of cities, put shoes on the side. Everybody loves that. They have crazy parties around it. That was for Adidas. We do little award-winning horsey games in WebGL. That was kind of fun. And we do Samsung things. We do a lot of Samsung things actually. This one is the smart TV demonstration thing, and there's the website as well. It works on phones, which is the future. Then we've got the Emergency team. We went to Rome. This is like brand new. We went to Rome like last weekend, and this is one of 2 pools we had in our little mansion complex thing. And we did have inflatable ducks and unicorns, which was great. And it was hot and sunny, and I have almost a tan. Yep, the calendar. So literally next week, we have Edward coming in to talk about GDPR. That's kind of a big deal because it's coming in next year and everyone's really panicking, and yeah, you should probably know about it. And then Bart is going to come in and talk about how he's hunted down criminal call centers in India. I saw it at Shah, and it was kind of hilarious. So that one I can highly recommend. Then next month we go back to our 1 a month schedule. Hank, who was meant to come in August, coming back in November, telling us how the internet works. He works at the Amsterdam Internet Exchange, which is where all your traffic goes through around the world, like core internet stuff. And then Phil Zimmerman, who invented PGP, he will come in hopefully and talk about privacy and things you should know. Then somewhere on the 13th or 14th, I haven't quite nailed down a date yet, we'll do like a end of year special in December. I'm thinking about doing some sort of raffle, like we give away free stuff, like more free stuff than we normally do. That'd be kind of cool. We'll do vaguely a testing thing with the speakers, like Mandy from Chef said she might do a talk, and then Bass from GitHub said he might do a talk. I need to nail these down, but they're in progress, so that's good news. And there's me sitting on top of a unicorn. You can get me on YouTube, and yeah, follow me on there. And if you have any complaints or nice things, you can say nice things. Samantha that's her like hashtag username. Or if you want to be super official, you can use Samantha@DigitalOcean.com, and she will get back to you very quickly. They're all in New York, so you have to give them time difference. But other than that, yeah, that's how you get contacted with us. Feedback is much appreciated. We had some last month saying they wanted microphones and a clicker. This is in progress. As you can see, we don't have microphones or a clicker, but we heard and we're doing, and we swapped the layout around, so now there's like room to chat and wander. So that is that. Does anybody have any questions? No? Okay, well, that's good news. Okay, so I will hand this over beautifully to Coen. Yep. And we'll get this show on the road. Okay. Might kill this. Yeah, that one. Yeah.
Okay, welcome everyone, and thanks Your Majesty for hosting us tonight. My talk is going to be about game engines and what's wrong about it, and my talk is going to include a lot of rants. So if everyone feels like that I'm touching that tool or the language or anything, like just throw questions at me. Be more than happy to get into a fight.
Is this code of conduct?
Probably not. There's also some swearing in the actual talk, so that might also be part of it. No, what I'd like to discuss tonight is going from game engines to creative coding. Well, most people don't start with building games and then roll into creative code. They either go from web or like OpenGL or web technology and roll into creative code, or just start experimenting stuff in open frameworks. I did it pretty much the opposite, or the other way around. I basically went from using game engines to developing applications for creative applications, which is an interesting transition, and also highlights a couple of the problems that are surface based on the differences between the two and what they actually are. So I'm going to take you on a journey pretty much from beginning to end, and where we are right now and what we try to solve along with the process. So a bit of a word on NAIVI. Was founded in 2015, so we're relatively young. I founded it with a ex-colleague of mine called Bas Korsmit. He's currently in the States. He left us, but he's still with us. It's kind of weird. He works pretty much double shifts. He works there right now at Ready at Dawn, that made the classic horrible game 1886, The Order. I don't know if you heard of it, PlayStation 4 game. But he just wanted to get a different experience, getting out of Holland pretty much. So left me alone and sort of with my hands tied, like what do I do, because we've got projects going on and there's a lot of tech that needs to be developed, but couldn't do it alone. So we got new developers in. So Jelle and Ritesh, who are currently in the audience, joined and are currently running NAIVI together with Stijn van Beek, who's also in the audience. He's our audio programmer, and Bas Korsmit is still involved. And we work with a tier of freelancers on the side. So most of us have a background in game development, and we all used to work at Guerrilla Games in the tools team. So we were building the tools for the engine and artists to be used to build games like Horizon Zero Dawn and also Killzone Shadowfall and the Killzones before that and before that and before that. So pretty much coding C++ all day, every day, but we also use things like Python to do hacks or get stuff done in Maya, for example. But over the time I sort of got sucked into a more technical realm. I felt like I was losing my creativity a bit and started dangling on the side. So I was starting to build LED panels and writing software to do VGAing in clubs. I was just a bit sick and tired of having to write asset browsers or sorry, just brings me back. Just brings me back. But I also wrote a lot of tools that had to do with terrain in Horizon Zero Dawn, which allowed you to scan a part of Google Maps or Google Earth and download that at high resolution and then bring that into the game as a stamp that the player could walk on, and that's the way we also designed the entire tool or terrain in Horizon Zero Dawn. If you have more questions on it, Dan sitting with us, who's doing a lot of talks on the editor we built for Horizon Zero Dawn, but for huge crowds. Anyway, 2015 we started, we were founded. We love working in C++, but we do have a love-hate relationship with it, and it's also part of the talk today. Next to that, we code in any language that's pretty much available or necessary, including JavaScript. And we are currently active in many sectors, including advertisement, art, games, post-production, and events. We've been doing things for Random Studio, Louis Vuitton. We've been VJing for Passpop, had an installation at ADE, worked with Your Majesty on the interactive cubes for Adidas, which is fun that you use it as a promotional thing. I'd like to rip it apart. And Guerrilla Games, I did the end sequence or titles as they hired me back in, and One Size with the talk. And they do mostly post-production, so visual effects. And there were more logos I could throw on here, but what I wanted to show is the diversity of these logos. And it's kind of weird for a company to be active in so many fields. Like we do advertisement, fashion, then we build an installation for ADE, and then we do post-production for One Size with fluid simulations, for example. I don't think there's a lot of companies that actually manage to bridge out that far, and that's mainly because we do code. We are like a code tech team. They're like, we have this great idea, but we have no idea how to get it done. It involves lasers, and it involves LED screens and MIDI devices and rendering to multiple screens. We heard you guys can solve this. So we just sit down, we're like, okay, these are the requirements, and we try to write stable code. But what we don't do is web technology. Everything that has to do with something with web, I generally don't take on. So my first question tonight to you is as well, which fields are you active in out of all of these? Like, who's doing web in here, in the audience? Ah, yeah. Okay, I have to tone down a bit, eh? Who's active in games? Yeah. Post-production, visual effects, anyone? What do you do?
Processing.
Processing.
Processing at the past, some VJing.
Bit of VJing. Okay. Yeah, and then we have fashion, but it's not like print, of course. But we generally get to deal with a lot of different people. Like then we're dealing with web people, and on the other end we're dealing with hardware vendors that have to do with LED displays. Then we are having to do with lasers, and the range is quite broad. So made this nice slide. And so when we come down to the core of it, it's like, okay, I always felt everything is sort of intertwined. For me, there's no difference between having to make a game or making an interactive installation or building a tool for Maya or for Photoshop or a plugin. The fundamentals are pretty much the same. Like, there's no difference. So for me, it's just code. There's math involved, often some sort of rendering and peripheral hardware. And I like to bridge those gaps. I don't see those fields separate anymore. And I think in the future we'll see them overlap more and more. So that's where I sort of found a gap. And it's like, okay, mind gap, that's where the title comes from. Why can't I just expose all of them and bring them together? So on the one end we have games, we have the art installations, post-production, we have the events and the advertisements, which are all the fields we're active in. But there must be something that bridges them all, like some sort of tools or a framework. And often every segment has its own set of tools. Post-production uses Maya, Nuke, Houdini, for example. Advertisements uses Illustrator a lot. Games are tied to game engines such as Unity and Unreal. Art installations use open frameworks or Cinder. And to me, like I said, there's not much of a difference. And that's also because I've used all of them. I've been part of, since I was a student, I've been using them all. So the next slide is a bit about a couple of the projects we did and sort of highlighting the various tools and tech we used to actually accomplish them. On the top left side, we have an installation we just finished for Louis Vuitton in Korea, which was an interactive installation built with Unreal Engine 4, where you had a plane and it was flying through the clouds and landmarks would pop up because Louis Vuitton, it's about travel or something. But if you, honestly, I hate this shit. But sorry, I can't, I have to make money and I have to do the big commercial stuff, you know, and I like traveling, especially for Louis Vuitton, first class flights, fancy hotels, just writing 4 lines of code and then fuck off. It's like, yeah, but Unreal Engine. So the idea was like, okay, this is the entrance to that big exposition. If you would walk in, there would be a sensor on top of your head, and it would register if you would, that it was some blob tracking. It would register you, and the camera would zoom out, and you would be able to move through the space and fly the plane, which is a very simple interactive dynamic, but it worked very well. Everyone got it. Granny's got it. The CEO got it. So, you know, it's like, oh, you're happy, like everyone happy, yeah. Oh, and in the end, they wanted a, like, there was some legal issues, but he explicitly wanted the Corcovado, which is like the thing you have in Brazil, you know, that's on the statue. And apparently the church has its legal rights on it, and they weren't able to put it in, but the CEO wanted it, so I added it in with a command line argument quickly, just for that one. That's actually why I was there. They paid a lot of money just for me to put that stupid thing in. But we also do Passport, for example, which was a VJ software I wrote. I'm going to highlight that a bit more in the future during this talk. It's built in C++ with our own engine because I couldn't do it with a game engine. I needed multiple screens, I needed to write my own LED drivers and LED interface, and I wanted to build my own GPU model for it. So I did. So I can't use Unreal Engine there. Then this was for Guerrilla Games. Was a title sequence, had to be done in 3 weeks. That was all Python using the good old Core engine, which is not Core anymore. It's called Decima. Sorry. Yeah. Some visual art and open frameworks. This was from Jeffrey Linneman. It's also custom game engine. This was using C++, our game engine, together with HTML, CSS, Touch, LSD. No. Hardwell. Everyone just mentions Hardwell. I put it in everywhere just to say like, oh, it's Hardwell. Horrible. But but we did the visuals. It was also the first bigger project we did with NAIVI. And we had to build the show visuals, and basically, pretty much it came down to using 130 BPM loops. Like it's like ding 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 ding. So like, so what do I make the visuals do is just like they gave me a loop. It's like just sync everything to 130 and you're done. So there's also highlights a bit my frustration with that industry because it's not creative at all. Everything is synced to 130 BPM beat. But also, what frustrates me the most is that you have to deliver everything as a video file. There's nothing real-time, interactive, or interesting going on. So what we try to do to spice it up is just make things procedurally in Houdini, or processing, and then it was piped to Resolume in the end. There's some post-production work I did in London. We built a laser installation. This is not a render, this is an actual laser with multiple mirrors that we laser cut and 3D printed. And this is an artwork we did for a band. This is like way long ago, but the fans could design their own artwork, and every time someone new started up the app, they got the previous work and they collaborated on the final cover. So, but my main point is many different engines, types of code, different fields, and I like doing them all. Like, I don't particularly like one over the other, except doing the super commercial things. But you need to, and I always smile. So what brings them all together is just data. I don't care how people look at it, how you treat them differently. Some people like you Photoshop. What I see in Photoshop is just a pix map. Some pixel data, some bytes. The same in Unreal. If I process some data in OSC, or I process some data, there must be a way to bridge data, get data from A to B. I never see a problem really. I always try to think in solutions. It's like the quotes are just rolling out of my mouth. Yeah, and there's some swearing in here, so hopefully that's okay. But really, literally, like, that's what I had to figure out. It's like, when I got started in art school, I just thought about using applications. And as I rolled and progressed in the industry, I was like, I don't care anymore. It's just, I can tie everything together, can use anything to work with everything. So, just to highlight that a bit, this is my personal career path, which has been like, kind of turbulent. So, yeah, I'm just going to write these. I'm going to spell these out because you can't read it in the back. I did art school, started as did audiovisual design, also graduated from it, meant filming things. Pretty much found out that I don't like doing that at all. I like to sit in my room and work on computers and not get out and have to direct people to do certain things to get certain results. So, but I did get to touch Maya at some point, and that sort of was the opening phase. It's like, oh my god, I can make everything on the computer and don't have to step out anymore, just go. But computers were very slow at the time, and I wanted to do photorealistic rendering, and I completely fucked up my, how do you call it, when you graduate? I basically walked in with nothing. I was like, I can't do it. I had the idea of having water drip from the ceiling, and just many ideas on like, but in the end I got to know, like, okay, 3D graphics is tough, especially photorealism is tough, and at the time the apps weren't as evolved and the renderings weren't as good as they are currently. So I was like, okay, I need to learn more about this. So I did a master in England in computer science, but tied to 3D graphics. And the main goal of that master, just get yourself into London, just get to become a post-production pro. So that's what I wanted to be. I wanted to be, work with the big studios, big film effect studios, and make effects. So I focused on dynamics. So I started working at Cinecide, and Cinecide is a post-production company in London, in Soho. And over there I was a Houdini artist. Does anyone know Houdini as an application? Hands up. No? Okay. Houdini is awesome. Literally, it's the, how can I say this? I started with Maya. Everyone knows Maya? Yeah. Maya is the industry standard when it comes to making graphics for film and games, animation, rigging, anything. But anything that gets a bit more complicated, like I want to destroy buildings, I want to have massive explosions, I want to have custom things growing. Maya doesn't cut it. What you need to do in Maya then is get a developer and develop a plugin for you. And the developer also has to understand Maya very well, because Maya has a very difficult API behind it. So there's a C++ API in Maya and there's a Python API in Maya. So what you end up doing is a lot of companies, and game companies and film companies, start hiring a lot of C++ programmers that have to work with the artists to build specific effects or tools for the effects to be achieved. Houdini pretty much solved this by opening up that set of options as an artist as a set of technical tools which are modular. So nowadays node graphs are super interesting and hip. Houdini did it in the 80s already, and it kept growing. So when you look at most of the things currently in film, which are complicated, they're pretty much always made with Houdini. So if you get a chance, or you're at home, check out this application, check out the demo reel and see what people do with it. It just opens up possibilities, and I'm going to talk more about that later. But pretty much I was a Houdini effects artist there and worked on Narnia, Harry Potter, and pretty much I ended up writing tools. And I couldn't code. That's a big thing to understand. I was not a very good coder at the time, but I did understand how to design tools for artists to be used within the film production pipeline. And Houdini doesn't, it slowly eases you into coding, but gives you nodes already to just get quickly going. So your mind is only blocking you, and slowly you grow in comfort, and with that comfort, you start coding better and better. So I took a different approach. Instead of sitting down, it's like, I need to code to make this, I was like, I want to make this, so I started making it, and then started coding to make it better. For some reason, the company that makes Houdini picked it up, and I ended up there. I moved to Toronto, and I built a fluid simulation pipeline, a couple of solvers that are currently used and still shipped with Houdini. And the solvers allow you to blow up buildings and set things on fire and make massive smoke effects, which are currently in use pretty much everywhere. Still something I'm the most proud of what I've done in my life, I think, is to actually build something that's been at the hands of thousands of artists worldwide and are in all the major Hollywood blockbusters. So, but what I did learn there was like, oh my god, these people are ridiculously smart. They were like only mathematicians there, and the mathematicians turned out to be brilliant C++ coders. And I couldn't code C++. I could use the application very well, but because Houdini is so modular, you can build your own solvers in it. That's how far you can go. That's how deep down you can go. You can build little micro solvers that you tie together to build bigger solvers, and you can input random data to be processed in a random way to create interesting effects, and things just keep growing and growing over time in that software application. So in the end, it shipped. It's currently still in there. Spent about a year on it, day in, day out, standing on the shower, looking at the driplets and thinking like, how the fuck, how do we make this? Like, how do you put this in algorithms? What's the formula here? And to this day, I also believe that photorealism, and people think that in film and all the things we've been making and seeing, that everything's possible. It's not. It takes hours and hours of simulating things, and then you still don't get the desired quality or resolution from your simulation. So people start hacking and building things on top of it just to make it look real, and also do it for a particular shot. So there's no holy grail, and it's still not solved. That's also why in games, fluid dynamics and explosions are generally the toughest thing to do, and always make it feel like a game. Like, we can do a lot with rendering and deferred rendering and passes to make it look good in a game, but when you see an explosion, you're like, yeah, that's a video or a couple of frames played back. Never feels volumetric. I hope that in 10 years time we're there, but that's also what I found at Guerrilla Games, which I got hired afterwards, stayed about 5 years there, started as a technical artist, ended up as a tools artist, a tools coder. And pretty much during this time I learned to code a lot, and I started with writing Python to write nodes that weren't very performant, and then like, okay, performance is an issue here, what do I need to get performant? Okay, let's dive into C++. Oh my god, I hate this, like, what is this? Like, it takes me hours just to get a project up and running, and it doesn't compile, and what does it mean, pointers and references and pointers to pointers to pointers? Like, oh my god, why? But you start to grow and love it over time, and you also see why it's so capable, because you can talk to all the hardware you want and at the same time get to an abstract level that you want for building your applications. So in games, everything is pretty much C++, as far as I can tell. Of course, Unity has a C# layer on top of it in which you can script, but in the end, they're all C++ instructions. So if you get deep down, you always end up with C++ in my field of work, and I like it because it makes me be able to write drivers, at the same time build good GUIs, and if you want to, you have a way to tie it to web or whatever else you can think of. But I got bored and I started NAIVI to bridge all of them together. So what I ended up learning last is architecture design patterns, but I knew the design patterns already from working with, for example, an application called Houdini. So also compilers, oh my god, you have to learn to understand C++, you have to get to understand compilers, and that's not a fun road. But I feel like I'm there, but there's people, I know them, they're sitting over there that are just, I hate them. So my big thing is like, how can you write a complex system like a dynamic solver before knowing any code. And it's just because you don't need to when you actually look at it from the right point of view, in my opinion. And also have the luck to be introduced to it in a certain way of thinking. So I'm going to explain that a bit by going on about interfaces and obscuring complexity. And that's why I want to trash Maya completely. Anyone that wants to start with 3D just starts firing up Maya at some point, and everyone tells you this is the bee's knees, like the industry works with this is what you want. Maya gets in the way of a lot of creativity in my opinion, because every action in Maya is a menu item, and you have to string together all these actions to create a certain effect. If you want to go back in time, you're fucked. You can just throw everything away, or hope Ctrl-Z gets you there, but also Maya's undo redo system is broken. So it will break your scene at some point, you might press save, you open it up again and it crashes. That's how broken Maya is. But it has a huge reputation in the games and film industry because it was the first sort of 3D application that was scriptable and programmable, because it has a scene graph behind it, and the scene graph allows you to see what the hell Maya is doing when it tries to compute something to come to a certain result in your viewport. So the graph is constructed in the background, but you can't read it. There's like millions of lines stringed together, and you have no idea how they intertwine or how they're connected. So people don't look there. But if you're developing for Maya, you have to, and you just spend hours looking at these graphs which are unrecognizable, and also having to understand how Maya deals with its data, when something is dirty, when something needs an update. It's an archaic 80s shit model that's still being used today, and people like, when you just go Blender, you know? If you want to make something in 3D, just go with Blender, or if you want to make complex things, go with something like Houdini. I just feel Maya is slowly going down the wrong road. That's because over time they haven't been adapting to the current state of affairs in 3D graphics and film and game development. So what they do is, Autodesk, who owns Maya right now, they kill innovation. They buy a product, it might be a competitor of something else, and then they just kill it, even though it has a huge fan base. They also buy it, don't develop it further, and just let it rot. There's no actual improvements release on release. They don't think about, when they introduce a new set of tools, how it integrates with the rest of the workflow, which means there's more actions, more menu buttons that you have to string together. And it has a very expensive licensing models. And I could know because I spent years and years writing C++ and Python for Maya. I also wrote the Houdini engine implementation for Maya which is pretty much running Houdini in Maya as a plugin. And then you get to deal with the intricacies of Maya, and it's just painful. So, but the thing is, Maya is so well integrated in most game engine pipelines that you can't get rid of it. And people just keep training themselves to use and deal with this old and aging model. And I can now see that most companies are slowly stepping away from it. I can just, again, talk about Gorilla. They had the engine running in Maya, and slowly they decided to take it up to build their own game editor, completely separate from Maya, and Maya is just a visualizer. You have companies that actually build game editors in Maya, which is, I don't think that's the right way to go anymore. So, boom. This is also the tool I wrote. So, you can make explosions like that with it. So, how does Houdini work or function? What's different? Like, what is the main difference between these kinds of applications? Like, first of all, in Houdini, you don't design an effect, you generally create a tool to design an effect, which I love, which makes it more procedural and reusable. And I love reusing things I've been building. It makes you start to think about what I'm actually trying to achieve here. Is there something I can take away from this to be used in other shots or in a different production environment? So slowly the film companies started seeing this as well, and now they have a huge team of Houdini artists actually building tools that get reused project to project. In Maya, it's impossible to transfer any of that knowledge or idea that you have in such an application one to the other. Also, what Houdini does, and Maya obscures, is it says like, I'm an open data model. And I'm like, what? Wait, like, what does it mean to have something show up in my viewport then? And that means you have to go into a massive mind shift. Like Maya says, this is a sphere, and a sphere has vertices and you can pull them. And then if you want to combine them, you click this button and you click your thing and then it combines them. And you have no idea what's really happening under the hood. What is it combining? What kind of data is it working on? If I want to work on a different color channel or do it based on the UVs, how do I do that? You know, it's like, Houdini is like, I don't care. Your points are an attribute. Your UVs are an attribute. You can make any sort of arbitrary data an attribute in Houdini and tag it on to the objects that you're processing. For me, that was a huge breakthrough. I'm like, fuck, it's actually quite simple. Everything's built up out of very simple code constructs, which are attributes in Houdini, but if you look at it from a code point of view, you just have an object and you tag data to it. It also allows Houdini to expand relatively easy. So they have a new model that computes. Like, have you guys seen a lot of the videos lately with squishy bodies and fancy colors that are colliding? Anyone? Yeah? That's like a hype. That's Houdini. It's all Houdini. Someone found a button or a magic preset and they're like, oh, this looks great, but Houdini does that, and Houdini does that in a way not seen before. And yes, it's difficult. This stuff is not something that you just pick up and run with. It took me 2 years to get very fluent at it. But by understanding Houdini, you understand OpenGL, you understand other graphics engines, you can start working on game engines. Unity wasn't a problem anymore. Things just open up. So, attributes in this case could define where a point lives in space, the color of something, the angle of which light bounces, how far something is from the surface, how fast something moves, the heat of a flame, which is a volumetric object. It supports volumes, which are the same kind of data sets, which are points, but then differently spaced, or a different object that constructs them. And you can work on many different levels. You have the object level, which contains the general knowledge, so it's your general app and your general code construct. But okay, this is my app, these are the objects that live in it. And every object contains its own set of additional nodes. And you can code those nodes using nodes, or you can code those nodes using Python, or you can code those nodes in C++, which is the most performant, but also the most difficult thing to do in Houdini. And generally, you never have to touch C++ in Houdini at all, because it has its own language called VEX, which is a single instruction, multiple data construct for nodes, which is like a shader. You just pour data in, process it on many threads at the same time, and actually bake it onto the result. And Houdini is very efficient on getting there. So this is just a string of algorithms I put together, and it grows something random, recursively based on a solver I've quickly whipped together in a couple of nodes. So then you're like, okay, I like this stuff. I love it. Like, I love these nodes, that combination. You can just like drag a box around it, press Shift-C. Then you say, okay, I want this parameter, this parameter, this parameter, apply. Oh, next project, bring it in, connect it up, and it works again. So, this has been designed and built in the 80s, and it's been booming the last couple of the last 10 years. And that's because it's a timeless design. And Unity and Unreal are basically not copycats, because they use it in a different way, node graphs. But now, nodes are becoming more and more popular to get stuff done. And as complexity of the film shots increase and complexity of games increase, you need better ways of actually getting there with better tools, or be able to build those tools relatively easily. So for me, this is a huge inspiration. It's been a huge inspiration my entire life. And if you haven't checked it out, just do it. And if you want to understand 3D graphics better, without having to do OpenGL or any of that stuff, give it a go. Press some buttons, see what comes out. Often quite cool stuff. So people say, yeah, it's too difficult. I don't want to be bothered with having to think of what my tools should do. Well, if that's you, never touch it. You want to use your millions of combinations in Maya to get anything done, just do that, you know? Or they can say, yeah, but Cinema 4D can do this with a press of a button. And that's because Cinema 4D sees things that happen in the industry and actually makes a button for it. But what if you want to be ahead of that button? You want to make your own stuff. That's where you as a creative person come in, and you want to design your own tools to do so. And that's pretty much, that's happened all the time. Like, you have software that drive what's possible, and then you have people that drive software to get beyond what's possible, and that feeds back into itself. But with its current state of affairs, clients want more and more. Louis Vuitton wants this thing running up and running in 3 months. Oh no, 1 month. Your Majesty wants interactive cubes in 3 weeks. So yeah, then you can't rely on buttons anymore. You have to rely on your personal understanding of how 3D graphics and interactivity works, and you have to start somewhere. You can do that in code, or you can use something that's a bit more agile, that introduces you to those concepts more easily. Because I think the best way to learn is by playing and not reading it from a book, and which in the end with C++ you end up doing anyway. So everything starts here for me. This is a node which I declare 3 points in, and then I say, okay, these 3 points actually are connected. So I give them vertices based on the point positions. So that's the index list. Index list becomes vertices, and that actually draws a single polygon. And I went to one site and I had to do a talk on Houdini, and the artists who've been active in the field, they had an issue understanding this initially because they're just used to making things work with buttons, which is mind-boggling to me because you make beautiful things, but it also takes a lot of time to get to those beautiful things. And if you just sit down and step back and look at what you're actually trying to design, in the end you have a huge time, you win in time. What I've often noticed in the film industry when I was working on Narnia, I often had to battle the Maya guys, and the Maya guys got there quite easily. You know, they're like, okay, this looks great, we have a beautiful simulation, a fire simulation, and then the client is like, yeah, scale it up, make this entire city burn down, and they're like, yeah, we can't do that. Like, okay, why not? Yeah, because like the tools don't scale, and you know, we need a bigger render farm. And then in Houdini you're like, oh, okay, so that might get there, so I'm building this little tool. It sets something on fire. It's not the most efficient, but it gets there. And then like, okay, oh, now I need to deploy it better. And then Houdini actually allows you to scale that up because you can anticipate where they might go to in the future. And also those tools can be used on a subsequent shot, so your client is happy, and your next production might go a bit easier. So in the end, everything ends here. Oh, that's no audio.
Do you have any volume?
Oh, this is 2012.
Yeah. 1 sec. Sorry. Yeah, there is. What the hell? Oh, it's the Intel. Oh, it goes over the Intel. 1 sec. What? How's it called?
Audio.
Yeah. Yeah, but you need to go through that stupid control panel. Yep, that's it. Look at that, Windows, eh? And now they also have a Metro interface on top of it. Yay! But anyway.
So do we have... Oh.
Yeah, now it should be.
Oh, yeah.
Rewind it.
I'm just showing you this because it was funny, because it starts here and every major Hollywood blockbuster ends up with destruction. Which is also what most time is spent on in these in these pipelines for these companies. These things are all simulated and then they're getting more complicated and complicated. And in the beginning they were using Maya for it, then they're starting to write their own tools, and in the end a lot of companies switch to Houdini for doing this. So Disney is on it, Double Negative is on it, all the major studios, Framestore, they're all using Houdini's flexible modular approach to building and constructing shots. And I still think this is the epicenter, because this has never been done before at this point in time. This was a huge leap in technical capabilities. It's a bad movie. It's a horrible movie, but this sequence was mind-boggling when it came out, in terms of the sheer destruction of things. can actually see the fluid sims are really CG when you just stop the frame and look at the detail that's associated with it. And they're all based on the same model. It's all Voronoi noise, scatter algorithms, and then impacts, and yeah. The models are quite simple, and just having huge render farms and being able to distribute your simulations over multiple computers allows you to get these results relatively quick. And most of it is also compositing.
This bar is offends me. Offended by this part of the film.
Well, at least they make it, right?
Yeah. When people get out.
Yeah, I think we get it. But yeah, I never really liked working on these shots. I had to do a lot of these things, and yeah, it's just time consuming. You set up your simulation, and then you press go to render farm. You come back and like it crashed after frame 4. And you look at the call stack or the log, but yeah, it's not really a lot there. So you try to set it up again and prototype that it's working. But Houdini allows you to scale up and down relatively easy. So you can set up a proxy sim, and it's like, okay, is this general motion good, you know, and does this feel right? And that's what you as a simulation or effects artist in this industry have to do a lot, is think about how can I make tools that are flexible, so I can get a general assumption of what the movement is going to be, or how the things blow up, or how the fire is going to look and move, and then just say, okay, scale this up, bam, 20 computers or hundreds of computers, go, 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 and it will distribute the grids, split them up, and then the grids start talk to each other, and they push the velocity data through, and in the end you end up with your 40 terabyte sim to be sent to a render farm somewhere. So this is something you can't do at home, and also that's what I tried when I was in art school. I was like, oh, this sucks. And also, it made me leave or get away from this, because in the end I found like, okay, these visual effects and approximating nature through simulations is interesting, but it always like you reach a cap of it. Like you can't go any further. It's those are the algorithms that's currently supported, and in the end you might get slightly better rendering techniques or slightly better simulation techniques, but I was like done with that field. I made the solver, it shipped, and I'm like, okay, happy, let's move on. So I was kind of happy that I can go to Guerrilla Games. But I also want to highlight something that is horrible about nodes, because you can't use nodes everywhere. And I picked this example why I quit Max MSP pretty much the moment I started with it. It's the first thing I built ever in Max MSP. And the last thing. And I called it Dramatically Scattered Chipmunk, and I used it to actually break up video, and then that video would go into Houdini, and Houdini would break apart the walls based on the movement someone was making. So if you would be dancing, the wall would break apart based on your movement. Shit idea. But also, like horrible, like I can't express any complexity with node graphs in the end. Especially in Max MSP, because Max MSP only allows you to build a single patch, and that single patch you can tie to other patches, but at some point you will lose focus and lose grip on what you're trying to do. So you end up with a huge spaghetti. And looking at this right now, I can't debug this. I can't understand a single part of it. But it did function, and it did get my result out at the time, but it also makes it horrible to share with other people. Like, no one likes to look at someone else's node graph, like, ever. If you ever used Unreal Engine and you've been using blueprints, like, no one wants to see your blueprint. You're like, oh, look at my beautiful blueprint. No one gives a shit. It's horrible. They can't use it. It's because they grow in complexity, and what might take you 2 lines of typing some code actually ends up being 10 nodes strung together, and those 10 nodes you can't really. A day later, you don't really still understand what you've been doing. And I've been running into this problem a lot. I love node graphs, I love working with nodes, but I can't really reuse them or reuse them in any other project. Houdini allows you to package them up, actually write documentation around it, and actually have different layers of abstraction within nodes. But most node graphs don't do that or offer that, so in the end, your project pretty much ends up being that thing. So, also, what's the problem is performance. Some node graphs get compiled into code, which is quite performant. Houdini does that. I know at Guerrilla Games we used it with sound. They get compiled into, the sound patches got compiled into code, which are quite performant. But this Maximus P, for example, doesn't. So Maximus P has a huge issue on the performance side, especially when it comes to video. So whoever thinks about doing stuff that is intricate and difficult with Maximus P associated with 3D graphics, don't do it. Just go somewhere else. Go into Unity, go into Unreal, find something else that might appear more drastically different or difficult, but in the end it will allow you to understand the data you're working with better and also make complex applications faster. Also, these patches are highly unstable often. Like, I don't know why I found. So, and everyone's like, why don't we use scripting then? You know, it's like, what's the benefit of scripting? And I agree, like after a long like going back and forth, and if I should actually put that here, I do like using scripting instead of using node grabs. But the problem is most scripting languages don't have everything that you want to express from a low-level point of view as a scriptable component or an object that you want to use. And it's really hard to write a good API, a script API, on top of a complex application, such as a game engine or something as like Houdini did. Houdini has a really nice scripting language called Python. I think at Greater Games we had one at some point. They're also building one, but it takes a lot of time and effort. Like, what does it mean to use script to actually inject code or tell a machine what to do, or an engine what to do? And there's a lot of back and forth there, and it takes a lot of time. But also making a node graph system that intertwines with your low-level code is quite difficult. So yay, then we have code, and you're like, okay, great, code. So I moved on from graphs, and now I'm doing C++, and I feel like a badass. Ugh. Love it, every moment of it. Not. Like, it's just mind-bogglingly complex to get C++ in your head and get working with it. What people struggle with most initially is just setting up projects. So say I want to make an app, but I want to use this third-party module and this third-party module, and I've already built this, and then you want to string it together. Does it need to be a DLL? Does it need to be a dynamic or a static library? What does it mean? Which compiler do I have? How do I resolve those dependencies? Oh my god, some preprocessor define got in the way of my build, and I get a really ugly call stack, like you always get, which you can't debug, and you spend a lot of time looking at. Thinking of you, Stein. So then they were like, okay, let's use CMake. Anyone experienced with CMake here? Do you like CMake? Yeah?
Better than Cobol.
Yeah? Just can you explain why?
Have you ever worked with Cobol?
No. I've heard of it, but never tried it. I already had enough issues with CMake. It's a language to use a language. It's like, yay, another language. But then CMake is quite... it works, and it allows you to just to explain to some people what it does. CMake allows you to build projects for you. So say I have my application, and I have OpenCV there, and I have a couple of math modules that I want to use, and I want to use the drivers for LED screen together. And you want to build it so someone on OS X can use it, or code for it, someone on Windows can code for it, or someone in Linux can code for it. CMake allows you to build the project structure, to say like, I want to include this and this, needs to be a target here, I want to include this and this and this, this needs to be a target, these need to be linked together, this needs to become a project, and in the end, I want to end up with my beautiful executable. But setting it up by hand is tedious, and especially doing that cross-platform. Actually getting that to work on OS X, Linux, and Windows can cost you hours and hours and hours and hours of your life. So I've been doing that a lot lately with my colleagues, and it just feels sometimes like a waste of time. Like, why do I have to do it? You know why you do it? Because in the end you might help people doing it as well. Like, other people won't have to do it. Just click a button, your project rolls out, press compile, builds beautifully. It basically means you don't have to get people... You save them the hassle of setting up really complicated problems or projects. With the stuff we've been doing with NAIVI, we had really difficult projects when it came to the dependency we were involving. I've been using open frameworks with tons of third-party modules that I often have to compile myself and link and build in, and yeah, it's not very fun. So hopefully a good CMake file, and if you get one, you're glad someone did that for you. Like, oh, I know the pain and trouble you went through to actually get that thing to build on my machine. So yeah, C++ comes with a steep learning curve, and you need to know what you're doing. Like with a node graph, the nodes take care of the memory and the management of the data for you. When you're writing C++, you have to do all of that yourself. So starting with C++, it's often a nightmare because you have no idea what the hell you have to do to make it safe. You have to think about all the memory management issues you might run into. Your code layout, threading if you want to use threading. And threading in C++, threading, as everyone knows, even in things like JavaScript or Python, can get tedious quite quickly. With C++, memory management on top of it, they become a nightmare. So the result is often crashing apps. And what I've seen in the creative industry quite regularly, because I've been to many shows in Milan the other day, I'm not going to name companies or anything, but we had a big LED wall with multiple people interacting with it. It was all done in C++ and our own custom engine. We spent months on getting it stable and solid. And the other guys, they were definitely more from a web development background. They also wanted to have this creative app, which was having fancy graphics and interaction and sensor interaction. And it was crashing all the time because they didn't test it properly. So they had no idea, in my opinion, what it meant to properly write something stable and good using C++, using your own technology. So things like open frameworks might give you a handle. It's like, look, you can make beautiful things, but in the end you always have to know what the hell you're doing, especially if your project and solution scales over time and you start taking on bigger and bigger and bigger projects. And code validation is not there. Node graphs validate your data before you actually run it often. So you know, like, okay, this node is not executing correctly because I'm missing an input. So your logger notifies you or the game doesn't run, but at least it's easier to understand and it's not as prone for crashing. Crashing apps are the worst, especially when you're demoing something big for a big client. It's your worst fear and it's my worst fear still. Something I always have to explain to other people as well. It's like, I don't care, like as long as this thing is there and it needs to run stable, and I need to make sure that every pattern I have in my mind actually maps to something concrete that is stable. And I pride myself up to this point with the company and all the installations we've done. That's been the case and the point. Yeah, it's been relatively smooth in that sense, but it wasn't easy. So with C++, you need to know what the hell you're doing. And text is not a creative, intuitive form of expression. Some people get over the hurdle, like, okay, I love code. And code is great for expressing myself, but I often find code cannot always do that for you. Like, code is not the best way of expressing yourself in terms of... you have to always translate what you have in your mind into some abstract concept that you have to put into code, and also have to deal with all the memory issues you're dealing with and how to get it optimized and how to send data to multiple devices at the same time. And then you have the compiling, you have to wait a lot, you get cryptic errors. And cross-platform development, like I highlighted before. Getting stuff with a lot of dependencies to build for MSVC, Clang, GCC, ARM, on OS X, Windows and Linux. That's pretty much half of your time, often. And a client might come over to you and say, okay, hey, can I get this now on OS X? You're like, oh. Why people, why OS X? No, joking. Not really. Hey! So, game engines, what do? In my opinion, they start to combine them both. Like, they're like, okay, so you can use nodes and you can use C++ to make cool nodes. And then you can use those nodes to put them in graphs, and you can put graphs in graphs. And in the end, that's a good idea, you know. I think game engines really solved something there, and that's why I think game engines are in a way the future for creative app development also. They don't really know this yet, although Epic Games is starting to realize it, because they also approach us based on the Adidas post, like, oh, they did something cool, which is not a game, let's put it on the website. That's true, because I felt like game engines could do more than just build games. And slowly at Epic Games, they've been realizing that in Unity as well. So, and I like it, you know. What Unreal Engine 4 does for you is like, okay, you download it, and then you like make new projects, you have a nice project setup window. Yeah, you can drag your thing around, you put a light on it, wow, it looks kind of cool, and you're like, okay, I want to code something. It built already a Visual Studio solution for you, it knows that everything gets compiled together and works together. And in a way, that saves people a lot of time. It saved me a lot of time. All the projects, and I've done a couple now in Unreal Engine 4, I'm grateful to them, and also that they made it open source. It's a huge advancement in technology, I find, when it comes to performant code running natively on native devices, hardware devices. And also, the blueprint system that Unreal introduced is really, really well made. It's interesting how they solve the pushing and pulling of data. You don't have to worry about it, but what you do need to know when you're working with Unreal is still you have to be a coder to use it. In Houdini, you don't have to be a coder to use it because you can just experiment a bit, you can easily follow the flow relatively easily. In Unreal Engine, you need to be a coder to build even node graphs because you need to know what the variables are, what arrays are, how objects link together, what a reference is. You might actually have to worry about copying data over or not, and that's something that C++ code doesn't generally deal with. But now you as an artist also, but using this allows artists to initially and eventually get into code, which is C++. And I find it a shame that there's no intermediate scripting language in between. And that's where Unity shines, because Unity said, fuck nodes, we're just going to go with C++, and on top of that we're building a very nice C# and Python script interface. And they did that really well. I think Unity has one of the best and most beautiful code design patterns and algorithms in there. And also, if you ever wonder what the best algorithm I find is that Unity has is smooth damp. Just look it up, you can find the code. It's one of the most simple, beautiful, automatic smoothing operations in the industry. Put it in everything. So, that's data-driven design for you. So instead of typing out all the functions one by one and actually tying them up together, and what's something you often do, you create objects that represent the data, and you can string them together, and the data is validated by the application that runs it, which makes things a lot more simple and safe. Unreal doesn't crash very often, and if it crashes, it's because of something low level or in the render engine going wrong or some data processing pipeline. At the same time, it helps artists to think about objects and data and how they flow through the graph. But when you start working with this kind of stuff, that's not the first thing you want to do. You might want to make a Christmas tree that lights up or something, but at some point you will get introduced to these concepts and it might seem difficult. But they're generally the right way forward, and once you have wrap your head around it, it's good. So,
5-ish minutes? 5-7 minutes?
Oh, we're almost done?
Yeah.
Okay, so yeah, then that's cool. So, bad thing about game engines is they're bloated. They ship with a lot of default content and code that you don't need. Packages can tend to get very large, and if you get stuck, something is not implemented the way you want, it only gets you 90% there, then you're fucked. You have to dive in, get into the source code, solve it. Garbage collection can be a huge issue, and you can't get to the rendering pipeline. Say I want to render something to a back buffer, and that's exactly what happened 2 days ago. This is literally 2 days ago when we tried to do something and couldn't solve it. Unreal offered no solution for it, so that meant going back and reinvent the wheel. Yeah, this is William. Yeah, he was like, that's why he was stressed today, because he had to actually go back all the way because his initial idea wouldn't work out, and he couldn't. The only thing he needed was to render a separate Z buffer pass on this GPU. And no, Jose, that's not possible. So I was gonna go through a couple of projects, but I'll
play the videos.
Yeah?
Play the videos.
Play this video?
Yeah.
Yeah. And I'll talk through the video, yeah?
Yeah.
This is the Adidas NMD project we did. We got 3 weeks. We built it in Unreal Engine 4. The idea was that it had 4 sides. And every site would be able to display a social media feed or a video or what was it again? Social media and Instagram. So we thought it was a good idea to use Unreal for this, and we got quite far initially, like that 90%, but then we had to get the live feeds more than 4 in there, and it meant having to write our own DirectV sort of webcam interface. It took a huge amount of time. Video player was broken in Unreal at the time, which meant random crashes. Really hard to debug, especially with that code base. I spent nights on trying to get that sorted. And in the end we got it stable and it ran fine. We were like Pakistani, sorry for the racial, hotline center here, just answering the calls and getting the stuff out correctly. That's why Christopher should have been here. And I said like, okay, it turned out great and everyone loved it, and Unreal picked it up as something like, look, it's great, and it won an award or something. But yeah, in the end, table flip. Like big table flip, horrible. Like never do this again this way. So The next big project we did was for Tommy Hilfiger, and they wanted a massive 10K touch wall, so the resolution was 10K. And they wanted 4 people at the same time operating with it. So 4 people at the same time needed to be able to interact with it, and it needed to render this real time, and there was like smileys and emoticons. You had to be able to swipe, you had to be able to select certain parts of the dress to look at. You had to say I want this, and at the phone you get your message that you received it. And we're like, okay, there's no way that I'm doing this in Unreal because there's too much GUI code involved. But also there's nothing really that supports this kind of rendering and layering and 3D graphics to actually get it done. So we started to write our own engine slowly to support this. And our engine is basically much a mix between something as Open Frameworks offers and Unreal. So you get the entity component structure in a way you can structure your data like Unreal, but at the same time set up your own render pipelines. And also hook up a lot of peripheral hardware and have a generic way of talking, having that hardware talk with each other. So in the end we wrote a custom render engine, we wrote HTML, CSS to texture renderer so they could use JavaScript and default HTML, CSS to get something done. This was for Random Studio. We had 3 months to do this. There were provisional speakers on top of it, which needed to be interactive based on the distance that you had to a sensor. So there were a lot of different hardware and peripherals involved. And we did this in 3 months, and it worked, and it's still running at their headquarters, and they've been in love with it ever since. Now Random is developing this further themselves, which is fine. But we also like making weird installations. So this is like, we use that same engine to build a laser installation that shoots lasers and bounces the light around based on 300 laser cut mirrors. I also like building visuals for LED displays. And it's using the same engine. I don't care if it's for commercial use or something else. So this is something we did at Passpop. And this is like an OpenGL graphics app where his instruments were interpreted live and resulted in all sorts of visuals. But it was running on the LED screen, and I wanted to use the LED screen not as a video display, but more as a way of like strobos. So yeah, you can clearly see this is just a LED display, but it feels more like a massive dance rig. I had a lot of fun building this, and we did a lot of shows with it. And it was real time when at ridiculous amount, a lot of frames per second. Yeah, people were liking it at the time, you know. So I like doing these things next to all the more commercial stuff. It was completely on the graphics card, so. And then, pretty much get that. So for me it's never important how things look on the screen. I only care how it interfaces, if it's performant enough, what's the frame rate. I'd rather write an interface using TouchOSC or someone else has a nice GUI library than having to implement all the GUIs myself. I don't give anything about it. I think an app needs to be stable, execute a single idea very well, and for interfacing I often use MIDI or OSC or something else to get there. I'll quickly go through this. So all this stuff which people hate, the code and the math that used to be combined, we've built our own engine. It's called NUP, and it's going to be released at the end of the year. And everything you've seen was pretty much built with it, all the projects. And it combines game engines, visual programming languages, and toolkits such as Cinder and P5, which is a JavaScript library. Hopefully people can use it to build something cool with it. So a couple of things that I like about what we've been doing so far is we don't specify main loops, which makes it very easy to embed our system, for example, into something else. In Qt, for example, say you want to write a GUI around it. Just use Qt and call the right functions in it, and you're done. It's cross-platform, works on OS X, Windows, and ARM. You can build your own render pipelines with it relatively easy, using the newest OpenGL standards, which is completely data-driven, and we solved multiple screen rendering. So you can have one object graph and it renders to X amounts of screens. You never have to worry about, what vertex array object belongs to what context, or how it is. In the end, you just say like, I want to draw this there, draw this there, draw this there, and you don't have to worry about any of the low-level context management systems that you normally have to deal with OpenGL. Also, you can build your own audio processing pipelines with it, which is Stijn has been doing. And he just got the framework and he started working with it, and now he's building his own engine into it, which is great. So it's easy to extend. You can build your own modules, components. You can script with it. So we have a really nice binding to Python, so you can build your own app logic using Python. It's very clear to read, and you can hook up anything you want and make it talk to the others in a very generic way. And every system can get their data from other systems relatively easily. We also spend a lot of time on configuring. So what I liked about, like I said, about Unreal Engine, that the data is validated for you. Our system does the same. If it's not validated, it will throw an error and revert to its previous state. So your data will never get into corrupt states, which is kind of nice to have. So in a way, you can hotload any content change directly into the app. So if you're like having your app running, say the Tommy Hilfiger, and they wanted to change the position of a button, change it in the JSON or using the GUI, and it directly hotloads into the app, and it's there, and it will stay there for the rest of your for the rest of the time it runs. And you can use rendering, audio, OSC, ArtNet, lasers, SVG loading, video playback. Everything is already in there because we've been building it. I've built media interfaces, audio interfaces, rendering. We use them for all the other projects, so people get them for free. So that's what we want to let people be able to do with it. Done? Yeah, because we're out of time. I can, if you want, I can show you a bit. I can code live for you, or show you live a couple of the things we've done.
You can do it during pizzas or something.
Yeah, exactly. So
Pizza coding.
I just ran a bit to the end, but thank you, and wait.
Okay, we don't really have time for questions, but you're hanging around for pizzas?
Yep.
Okay, so we do pizza coding and questions during pizzas. We're going to have like a 2-minute break, because my worry is the pizzas will turn up before the speak finishes. So yeah, drinks, toilets, be back in a minute. A quick break. Ben is going to talk to us about his production of music software that uses a non-linear way of doing things.
Yeah.
You can tell I don't know very much about music production, but hopefully you'll shine a light on this.
Yeah, hopefully.
And yeah, that'll be good. Cool.
So yeah. So what?
So nice warm welcome with a drink.
So what I was going to do, I was going to show you a couple of projects that I've worked on before, and hopefully that will kind of show you the direction I was travelling and why I decided to make Iris. So I come from Manchester. I've spent a lot of time in clubs doing visuals. I started kind of off in Max MSP, doing kind of live visuals mainly for techno people in clubs. So I thought I'd show you. This is the music's by Kevin Gorman, and this is just like a little kind of max patch with kind of real-time 3D mixing up with vertices and colours. Yeah, and I just project these into clubs with some projector mapping sometimes not. And then from there, I really love coding, but I found Max MSP to kind of get very complicated very quickly. So I moved into open frameworks. And at the time, I was really into the work of John Whitney, who was one of the first people to do computer graphics. And what I wanted to do was to take his algorithms that he'd been working on and make them real time and perform with them. So this is the software that I'd use to perform. And I'm just kind of, it's just kind of taking click events now, but it's kind of hooked up with MIDI. So when it MIDI messages came in, it would kind of automatically change. And one of the things that I kind of realised that by doing this and kind of working within this field is it's really important to kind of have the point of creation of your visuals and your music at a very similar point. At the very start, so you can have them running along at the same kind of track. Because what tends to happen, or the way I always used to work, was I'd spend a very long time making some audio, then a very long time making some video, then right before the performance, I'd just fuse them together, and that was the performance. But what I kind of wanted to do was have one side feeding off the other side. Oh. And then I kind of got more and more into making audio kind of apps. And this was for Audent, who were commissioned by the Tate to do like an app to do with the Ellsworth Kelly painting. So this app enables you to kind of explore the painting through sound. So kind of what it does is you've just got a little player head here, and you can move it to the different squares, and it sends out MIDI. But the mapping from the audio to the colour is totally logarithmic. So it's trying to interpret the painting through sound. So you get the idea. You put it on a square, and it interpolates that square into sound. Oh, sorry, I keep pressing escape. It seems to be the button I should press. Then I wanted to make Iris. So Iris is a visual musical sequencer. And I'll show you this little kind of introductory video, and then I'll talk more about it.
By imagining how a visual sequencer should work, we rethought how time can work, and Iris was the result. The first nodal software sequencer made as a tool for producers. Plug it into Ableton Live, Logic, Cubase, or anything else that uses MIDI. Iris frees you from the constraints of the timeline, so you can create and jam musical structures on the fly in intuitive ways. Sequences are arranged across Iris's spaces, and each node has physics. Move one, and it moves all the others connected to it. Build variations, tween between synth settings, and create tracks from these variants. Iris lets you trigger different instruments within a single sequence, giving you new ways to build and overview a track. Creative techniques, such as switching the direction of play or mixing time signatures, are now straightforward to realize. Iris is a non-linear sequencer. This lets you focus on making music because editing is easy. Iris replaces the traditional keyboard with a 2D matrix, providing easy access to all notes. This grid also incorporates musical scales visually. You can now see the notes in a given scale. We've integrated the Novation Launchpad to be the perfect companion to Iris. Key controls are laid out on its grid of buttons for screenless jamming and performance. Iris is the essential minimal visual sequencer. Iris offers a versatile and powerful approach to making and performing music. We've tried to make it creative and intuitive, freeing you from time and organizing your thoughts into space, so you can use your visual as well as your auditory cortex to make music.
So it's a visual sequencer, which has got rid of the timeline. And I think when I kind of started this project, I was really aware that kind of from the dawn of people making music until now, if you wanted to express it in a written down scenario, you'd start with a timeline. You'd always draw one note after another note. And what Iris does is it removes the timeline. And it gives you, because now there is no timeline, it enables you to kind of focus on the structure of the track and be able to jump from the start of the track to the end of the track to the middle of the track, but also tween between all of those different settings. So it's a really powerful way of making a track very quickly. Also, because it's not confined into boxes anymore, you can have kind of this note being a drum note, this note being a synthesizer, this note being a piano, and just chain all of these different things together. And kind of with Iris, it's really time accurate. I think there has been kind of other nodal software sequences for music around before, but they're always not time accurate. So this Iris actually enables you to be able to make beats with it. Yeah, so non-linear sequencer, and tweening between places is exceptionally powerful within Iris. Kind of all the colours from Iris come from the work of Isaac Newton's colour to tone. But for me, I kind of put it in just because I needed some colours, but I don't really like transposing colour to audio. I think it's always kind of down to the user to decide what the colour is, and I don't think there's anything innate about colour choice and sound. It works really well with the Novation Launchpad. So all the colours that you see on the GUIs are represented on the Novation because it's got RGB LEDs. One great thing about it is it doesn't just control music, and I think as Iris kind of goes down the line, it kind of already works with DMX, so you can start working on your light show at the same time as you're working on your sound. But I'd like to kind of extend that into visuals, and I think because there isn't a timeline, it's going to be great for doing VJing with, because of the way it's set up. Iris always knows when the next note's going to be played, so from being able to loop a piece of video footage dynamically live, it always knows when that next beat is, so it can time it perfectly at the point of it triggering the video. And then this video just kind of shows one of the great things about Iris is you can change the direction of play, but you can also change the note type. So sort of see here, you've got one line saying the note will go that way, but no line here. So every time it hits that note, it's going to change to this side, so you can control the way the time is going to go around. And this kind of makes it be able to kind of do generative sound with it. I'll show this little video. So this is how you draw a little loop. You can also do really nice feedback stuff with it. So now it kind of changes direction as it's playing, and you can make these like really nice little kind of rhythms and make them kind of as complicated as you want, but just from this very simple starting. And this is kind of, it's not kind of fully implemented within the system at the moment, but this is showing how it would work with DMX moving lights. And they're all just looking at one point at the moment, which is going around in the middle of the screen. But I can imagine that kind of going back with the John Whitney Rose kind of algorithm stuff with all these kind of DMX moving lights, making a pattern. And then this is Iris just using some DMX lights kind of straight out. So the light program that you're about to see is programmed live in Iris along with the visuals. So it's making the stage lighting and the song at the same point of creation. And of course you can save it all and bring different parts into different projects. And that's Iris. Hope you enjoyed it. Thanks.
There is time for like questions. I just have to sort out like some heaps of bits.
Yeah, if anyone's got any questions.
Like, a few questions. Nobody has any questions. Okay, well, in which case, go for it.
You were mentioning time accuracy. Is there a way also to loosen that up?
Yeah, for sure. One thing I like at the moment, I'm aware that in musical instruments there's a thing called swing, and you can turn it and it does some amazing sound things. And I want to do the same thing, but I'm not quite sure how it works just yet.
Well, I think nobody does.
Oh,
Yeah, how you wrote Iris?
oh, it's in Open Frameworks. In Open Frameworks, and it uses Box 2D for the physics. Yeah.
So if you want to add something, like is a scripting or is C++ completely? So you want to add something.
There's no scripting in, like, apart from having the project. There isn't an input to be able to do any scripting, but I think maybe in the future.
Yeah.
How did you integrate it with the DAWs, like on Ableton?
It's just MIDI.
Just-
Yeah. So you just listen. You can listen to Ableton on multi-channels, and then Iris works on multi-channels as well.
Yeah, there's this project that's a bit similar called Yanix. We're using OSC. Is that one of the ones that you mean when you mentioned time?
No, I've not heard of Yanix. Is it?
Yeah. So, yeah.
There's Nodal. More of Nodal. Okay.
Cool.
Thanks.
Okay. Thank you. Got one more question.
Years ago, I saw like a platform with the object on the surface, but the more or less worked. Like the software usage is this.
Sorry, when it was on the bench.
It was like a surface, yes, with the object that you can interact.
Oh, the React table, yeah. I think that's more for synthesizers. So it doesn't, as far as I'm aware, it doesn't have like a timeline in it. It's more like a synthesizer. Whereas I think Iris is more like a.
This sequencer was the same one. Is it?
Oh no, it's not the same one.
Does the distance between the nodes affect the time?
Yeah, so the distance between the nodes is the time that it takes, and that's uniform across Iris.
But it's quantized, right?
Yeah, quantized to the smallest you can go is 1/16 at the moment, and that's just because screen real estate is quite small. I think also in the future, at the moment you're kind of just seeing it directly down from the top, but I think I want to put it into 3D, so when you're looking at the nodes, they'll be kind of at different heights, and there'll be like these constellations in space, and then the lines going between them, you'll be able to choose that line to be like your automation data and draw in a curved, so when it's playing that sound, it's doing this on the curve.
So you can DJ in VR.
Yeah, I think it'd be amazing in VR.
Nice. Okay. Well, yeah. Thanks for your chat. I might have missed it, but it's probably good. You can watch both chats back on YouTube. I will send a link around afterwards. Yeah. Thank you for coming and speaking.
Pleasure. Thanks.
Yeah. We now have like a wall full of pizza, so that's great. I will just clear off over there and serve it up, and then you are free to munch, and I'll hopefully get some more beers, and yeah, stay as long as you like, and have a fun evening.